so this is the second part of this lesson, or maybe it will be a whole lesson, I'll decide later. So we looked at different types of energy. Now there was one energy that I forgot to mention. I wrote it, but I forgot to mention, and that's nuclear energy. Okay, so nuclear energy is basically some materials in our world, like uranium, has this nuclear energy that we can convert into electricity. Okay, we're going to mention it a little bit more next year, but unfortunately we don't actually learn a lot about nuclear energy and nuclear physics in this country, which is a shame. Okay, so you just need to know it's a type of stored energy. We can release that energy through a certain process called fission, but you don't even need to know that word fission. Okay, right. The cool thing about energy is that even though we have different types of energy, as we already saw, one kind of energy can become another kind of energy. We've got energy, we call it energy transfer. Okay? And that's really the cool thing about energy. Like we can convert money from rands to pounds, to dollars, to euros. We can also convert types of energy from electric to heat, from heat to sound, sound to kinetic, all that sort of stuff. Okay? So what you're gonna be able to do is look at a certain process, something that happens, like a man running or whatever, and figure out what's the energy transfer that is taking place. That's the kind of question you're gonna do in a test. Okay? So let's look at the most simple one: falling pen. Okay? Pen is falling down. What kind of energy does it have in the beginning? It has gravitational potential energy. Okay? Now from now on, I'm gonna write, instead of gravitational potential energy, I'm gonna write GPE. Okay? So gravitational potential energy, as it falls down, becomes kinetic. Okay? Now, if this object continues to fall down, then that's it. Gravitational potential energy becomes kinetic energy. But at some point, it probably will hit the floor. When it hit the floor, it's not moving anymore, so it doesn't have kinetic energy. So what kind of energy do we have now? Well, you heard it, therefore it has a little bit of sound. Okay? But also because objects hit each other, okay, whenever objects hit each other, a little bit of heat is generated. And you can do that with your clap. If you clap your hand a little bit, you can feel that you're generating a little bit of heat. And you can probably guess even why. When two objects hit each other, okay, the molecules start vibrating a little bit more, which means the temperature rises a little bit. So also a little bit of heat. Okay? A lot of the times we're going to have two types of energy come from one. Right. Burning paper, we demonstrated that. We said that the paper has, first of all, chemical potential energy. Okay? Guys, it's very important to write out PE, standing for potential energy. If you just write chemical energy, if I'm strict, I won't give you full marks for that. So whenever it's a type of potential energy, stored energy, you need to call it potential energy. Or PE, I'm fine. So the chemical potential energy, as the paper was burning, gave us heat, but it also gave us light. Okay? Right? Because we could see it. Now, this is, let me just stand there. This is a very common mistake that I see with students in the paper. So instead of writing chemical potential gives you heat and light at the same time, what a lot of people will say is chemical potential energy becomes heat, and the heat release light. And that's wrong. Okay? The light didn't come out of the heat. The light came out of the chemical potential energy at the same time. That is a big point, and I'm seeing it year in, every year I see 20% of the people get it wrong, at least. Okay, so don't be that 20%. Let's move on to watching a video on the phone. Okay, so you know the video of on the phone, you got light. Okay, you're gonna have light. You're gonna have sound. Okay, but where was it before? Okay, before it was. Let's try it a little bit closer to there. So we had light and sound. You have to ask yourself, where did that energy come from? Well, that energy comes from electric energy, right? If there's electricity involved, okay, then it must have electric. And electric is a stored energy, so we must call it PE, potential energy. So the electric energy became heat energy, light energy and sound. Okay? Actually, also some heat is released. Okay? You know, you touch your phone, you can feel the heat is released a little bit. Okay? Especially when you're charging it, really. Right? But some heat is always lost a little bit. Now, you've got to ask yourself, where's the electricity coming from? Well, in all our phones, we've got batteries, okay? Some devices like desktop, I don't know if you had desktop, okay? Not laptop, desktop. They don't have batteries. You have to plug them into electricity to the wall. So there's no batteries there. But your laptops, your phones, all have batteries. So what power, where does the electric energy come from? From the battery. So before that it was, okay, what kind of energy does a battery have? We didn't really mention that. In a battery, okay, there are some chemicals. And they go through some kind of chemical reaction. And in that chemical reaction, electricity is released. Okay? So you probably already guessed, batteries have chemical potential energy. Okay? So really in the phone, we start with chemical potential energy that then is get converted to electric potential energy, which is then converted to light, sound, and heat. Now you can even go backward and say, all right, but how did we get that chemical energy in the battery? And you can answer that, that's fine. How do you get the energy? How do you charge your battery in the phone? You connect it to electricity. So really, chemical energy was converted from electric energy. But at some point when you say, okay, where do we stop? Okay? And that depends on what I'm asking in the question. Right, throwing a stone using a sling. Okay, so I've got a sling, I stretch it and I let go. So at the end, the stone is moving. So the last bit is kinetic energy of the stone. But before it was released, the sling was stretched. The elastic band or whatever it was is stretched. So what kind of energy it has? It has elastic. Elastic, and remember, it's a stored energy, so we have to say potential energy. But now, to stretch it, I first of all had to move my hand. So I needed some kinetic. So I stretched it, meaning I moved my hands and the sling, that was kinetic energy. I stored that energy in the form of elastic energy, and then I let go, and that became kinetic energy. Okay? So these guys are, one more. A swing. Swinging on the swing. Whee! Like this. Imagine you're swinging on the swing. Now, how do you start swinging? First, you go up. Right? You go up on your toes, right? On your tippy toes. That means you're going up. It means you got gravitational potential energy. Now, you let go. You start going down, and you're going faster and faster and faster. So you're getting kinetic energy. Now, you're going fast. Do you stop in the bottom? No, you're carrying on. You're carrying on up to the other side. You're slowing down. Why? Your kinetic energy is running out. What is it being converted as you're going up and up and up and up? To gravitational potential energy. So it goes back to gravitational potential energy on the other side. Now, do you stop up there? No, you start swinging down. So gravitational potential energy becomes kinetic energy. And then you go up to the other side. It means you're getting more gravitational potential energy. And then kinetic energy, gravitation. Now, does it go on like this forever? If you swing yourself once, that's it forever? You're always going to be there? No. If you don't do nothing, you eventually slow down. So the energy is getting lost. We will see next lesson that it's not possible. Energy never get lost. But there is some kind of energy must be stolen out. Energy is constantly lost here. Okay? Energy is lost in this case and also lost in this case. Okay? What happens is, as the rope moves, okay, there's friction between the rope and the top. Okay? And whenever there's friction, like between your two fingers, do with your two hands like this, you can feel what happens if you do like this. You do that on the cold there, right? Why? Because you're releasing heat. So every time there's motion, okay, some heat is released. And that means energy comes out of the system and eventually you will slow down and stop. Okay? So I'm going to ask you underneath to do some energy transfer diagram. These called energy transfer diagrams to a bunch of process that happens in nature. Okay? See you guys next lesson.